Thank you very much. Just in the interest of time, I think we'll keep on moving on. Your computer's just there. So if I can ask Rich Carne to come to the stage. Rich actually comes from the MetOffice in the UK, which might not specifically seem like it fits within a smart cities context, but he'll certainly give you an overview in terms of what they're planning as far as working with smart cities.
Thank you. I'll give you a bit of an introduction to myself first, because I'm sure that not very many of you know me. So yeah, as Denise said, I'm Rich Carne. I'm actually the Chief Digital Officer at the MetOffice. So I'm responsible for the digital vision of the MetOffice and ensuring that we can maintain our reach and ensure that the public are aware of significant weather events that might affect them. Prior to that, I was the head of applications, so I've had some experience of developing weather applications for both defence and civil purposes. And even way before that, I actually developed them myself as a programmer, so I have some technical experience. And then stepping back even further, I was a member of Her Majesty's Royal Marines, so I've actually had some on-the-ground experience as well in terms of weather impacts and how they challenge and affect us, and the benefit of having good information and insight into a situation. So my presentation today centres around connecting the citizen for protection, prosperity and well-being. And so the main focus of the MetOffice is certainly around ensuring that we work at the forefront of weather and climate for protection, prosperity and well-being. And just to unpack that a little further, it's our job to protect lives, not specifically protect lives, but ensure the protection of lives and property, to increase prosperity by allowing people to make good decisions. And I think that's the vital part of our role, actually, is we ensure that people have the information and the knowledge that they need to make really good decisions. Quite often this takes the form of risk mitigation, so by offsetting risk against either life or cost. And whilst we can't change the weather, we can make small improvements in accuracy or additional time gained by early warnings that can really make a huge difference in the action that's taken. So what I'll do is, just for context, I'll explain a little bit about what the MetOffice does and the sorts of operations we do, and that'll help frame the further sort of smart cities discussion that I'll elaborate on at the end. So in order to accurately model the Earth's atmosphere, we start off with a whole bunch of observations, and actually this involves 190 countries from around the world, and all sharing observational data. It's a range of land, sea, air, space observations. This is currently a closed network of observations that are shared between the national Met providers as part of the WMO, which is the World Meteorological Organization. So 6 million messages are shared on a daily basis. So you can imagine, you get a sense and feeling of how much data that is flying around. It's quite exciting. This activity has been taking place for over 100 years in one shape or form, so we've been sharing this information between the community for a long time. Our operational forecast systems that we currently have available to us with our current supercomputer power can roughly be divided up into 3 parts. So we've got the UK model, which is 1.5 kilometres, and that's so at every 1.5 kilometre grid square we've got a point there which has weather information about it, and we model that. And that's not just in the 2 dimensions, that's in the 3rd dimension, because we have 70 levels in space up into the atmosphere, because we forecast for aviation as well, and they tend to spend most of their time in the upper bits rather than on the lower bits, and that's where they're most interested. And then there's obviously the temporal element as well, because weather never stays still. It's both spatial and temporal. Just some thoughts about size and amounts of data. So we get 100 million messages a day, so 300 gigabytes of observations from that closed network. We then produce 4 terabytes of information for our operational models, which are the UK-based one, the regional one, and then a global model. And then climate research produces a further 52 terabytes of data. So we're not talking about massive amounts of data, but it's fairly significant. So we've been struggling with the big data challenge for some time. So what do we actually do? And I've put this slide in because hopefully it elaborates on the concept of making decisions and what's involved in making a decision. So what the MetOffice does is we have a whole bunch of wisdom around science of the atmosphere and the way the fluid dynamics of the atmosphere work. And that wisdom we impart into knowledge, so an understanding of that. We then produce data, but I'd argue that certainly data can potentially be dangerous out of context and not being read if you don't understand the context. So we actually prefer to talk about information rather than data. And that information then can lead to a decision being made. Where these endpoints differ though, we have to set up and create a whole separate stream of wisdom, knowledge, data, information and decision points, because the user needs for an aviation individual are very different from someone operating a transport company that are transporting goods across the land. So we find that we have to set up three numbers of different streams. So I'll move on now to how I see us sort of connecting the citizen. And there's been a lot of talk this morning about what smart cities is, and I'll just add my own thoughts to that as well. And I think that the important element of smart cities is actually connecting the citizen. After all, what's the point of a city? The important element of the city is obviously its people. Without the people, there's no city, is there? So I think we need to certainly focus and be citizen-centric or user-centric in our thinking. So putting the right information at the fingertips of the citizen is vital. And I'll elaborate on that with a challenge that we've seen most recently that caused some significant trouble in the Philippines. So what makes a smart city? I would say it's the awareness of and the interconnection with its citizens to ensure that the safety and prosperity and well-being. So for me that sums up what's important about a smart city. I've got some movies too, so the other presentations have been great, so I thought I'd throw a movie in. In 2013, a devastating typhoon struck Indonesia. So this is actual imagery from Indonesia. That typhoon killed 6,000 people and affected 11 million others, and it caused $2.5 billion worth of damage. So it's not an insignificant event. What's interesting about this event is that the Filipino people are used to typhoons, and they take shelter from strong winds in these underground shelters. But in this case, the greatest danger was actually a storm surge, so slightly different from strong winds. And what we're seeing here is the top sequence is the actual observation of that storm. That's actually what happened. That's real live satellite imagery. The bottom one is a model, a forecast, or an interpretation of what we thought would happen 2 days before the event. And Pagasa, the Filipino Met guys, actually knew that there was going to be a storm surge. But what use was that information if we then couldn't connect it to the citizens who merrily went and sat in these underground bunkers, and unfortunately 6,000 of them then lost their lives through the storm surge and being drowned. So, whilst we can't change the weather, we can increasingly better predict it, and many lives would have not been lost if a better decision had been made. So if we had got the right information to these people, then we would be in a much better position, and we could have seen a lot more people saved and a lot less damage. So for me, I think the impact here and the challenge is in trying to fix this problem can be solved in a number of different ways, and I see smart cities as being key to that. So just highlight some of the things that we're up to. At a recent hackathon, I was really pleased with the outcome of one of the groups. So the MetOffice sponsors hackathons as a way of developing and generating innovative ideas. And this group were talking about flooding, and they thought, well, wouldn't it be cool if we, on everyday objects, we could build in features that would warn people and alert people to significant events. And this is a lamppost in the UK. I think maybe you guys know it as a street light, or it's an overhead lighting system. It's a lamppost in the UK. If you've watched Narnia, then you'll know what I mean. There's no fawn in this thing. But the idea was that they would use an everyday object that is in place already in the city to augment it and build some additional information into it. So being able to put information about flooding risk or strong wind risk and so on could be a very clever way of informing the citizen of the situation. And I'm sure that kind of use case is reusable throughout not just environmental impacts but others as well. So I certainly see a huge explosion with regards to the Internet of Things, and it's going to be vital for us to be able to both harness that and also understand it and control it and join in with that movement. I think standards are going to be vital in that space. Mobile as well is, I think it's certainly seen, and I started off thinking about this in terms of a very Western view, and Stephen's corrected me on that, but mobile for me is very centric to us as Westerners. It should be it is the hub of our connection, so that's what I mean by being at the fingertips of the user. That's the sort of device that we can implement and get information to the user. But yeah, beyond that, how do we think about other ways? So perhaps lampposts are the way to communicate to people that don't have mobile phones. So I think that the challenge for us here is around understanding what's being created, the devices, the objects that are being created, and developing standards which allow us to ensure interconnectivity. In fact, I'll talk about interconnectivity a bit more here, and this is another example of what we're trying to do. I see the connected vehicle concept as one that's of great interest from an environmental perspective. Certainly right now, we do see some environmental information heading towards the car, so we can see fairly basic environmental information that's quite site-specific. So you may have a city forecast for Exeter, where I live, and you may have another one for London, and then you might have a few cities in between. But then there's huge gaps in that journey for me between Exeter and London, where I don't know what the weather's doing. We do have we've got answers to those gaps. We've actually got the observations, and we've got the weather forecast for that particular route, for example. So I can certainly see the way we can introduce more high-resolution information into the connected vehicle. But I'd also see much more benefit in it being a two-way data exchange, so a two-way agreement. So pulling information out like whether the windscreen wipers have been applied or not, and associating that with a location, we could start to see a network on the highways of certain activities going on. So we'll start to see more cars turning the windscreen wipers on. That should indicate that it's probably raining where those cars are. Vehicles that are applying their brakes and the ABS is kicking in, the anti-locking brake system. There's quite possibly either ice on the road or some sort of other contaminant on the road that's causing them to slip. That information could be vital in preventing collision and road traffic accidents. But not only sending that information back to some central anonymous hub, but also what about an interconnection of the vehicles themselves? So the beauty of the Internet of Things is that everything's connected together. So could those vehicles communicate to each other so that the vehicle 100 metres up the highway that's turned its windscreen wipers on or suddenly slammed on its brakes to say there's a big ice patch here, warn vehicles on the same network of the same risks? And as we see more automation in the automotive industry, I can see vehicles being able to respond to that automatically, turning on infrared headlights when there's fog, for example, priming those infrared headlights, doing clever things with engine management systems in cold conditions and so on. So there's a huge potential in that space, and the MetOffice are currently in early stages of progressing that and understanding what might be involved. Another area of interest is our weather observations website. And the concept here is that we've created a platform that enables the curation of environmental impact through crowdsourcing. So I talked about that big closed network of observations that no one else but us and the other Met services can get access to. Well, this is the antithesis of that. This is a very open platform. It started off with the thought that we could actually engage the crowd and pull back their observational data. We have a lot of what we call weather geeks in the UK that all think that they're great at forecasting and so on, and they buy these observation stations that read the weather, the wind speed and so on. And we actually thought, well, why don't we connect them into a network which enables us to gather that information. So that's how it started. And over the last 3 years, we received 300 million observations into this platform from the UK observation and sort of some of the European observation points as well. And we expanded that over the last couple of years to include the concept of impact. So not only just getting the actual weather information, which is a little bit geeky, but also getting back how the individual has been impacted by the weather. So whether it's they're stuck in a snowstorm on the road between their house and work, or whether they're flooded in. So gathering that sort of information and pulling it all into a central location, which is not only pulling it in, there should actually be some arrows going out of this, because the other part of this is an API which allows access to anyone to connect into that data and make and reuse it and visualize it for their own purposes. We've partnered with ABOM, the Australian Bureau of Meteorology, as well, and we've implemented the same platform in Australia now, and they've received, coming on for 100 million observations themselves. So we see that platform as quite an exciting move towards the crowdsourced environmental impact concept. got another movie for you now. This is another topic, space weather, and it's not a joke. Space weather's real. I would hopefully give a bit of an explanation. I'm certainly not an expert in this area, but space weather is, in essence, the stuff that comes off the sun that affects the Earth. And the things that come off the sun, either solar flares or coronal mass ejections, or the electromagnetic radiation. Now, it has a huge impact on us. So, for example, what you're seeing here, I'll explain it actually. So the yellow dot on the right-hand side is the Earth, and the white dot in the centre is the Sun. And the Mercury, Mars, Venus are on there as well. But what's of interest, if you see that big explosion there, this happened in the run-up to the London Olympics, and this was a huge coronal mass ejection that just missed the Earth. You can see it just misses the Earth. The same sunspot which caused that mass ejection was only a few days earlier, I think 10 days earlier, pointed at the Earth. So had that exploded then, it might have been a different story for the Olympics. Actually, we might not have had too much power. So why is it a challenge for smart cities? Long conductors, like huge power networks, are heavily affected by solar activity. So much so that in significant events we can see power grids switching themselves off to protect themselves from the extreme impacts of them. The UK government has raised space weather as number 4 on its national risk register. So it's up there with things like pandemic flu as a risk to national infrastructure. And so this imagery shows the massive release of material, energetic particles hitting the Earth potentially. And I think that, again, this is an area where what the MetOffice has done is taken leading science from NASA and our colleagues in America and implemented it within a 24/7 operational centre in the UK, which allows the warning and the forecasting of significant space weather events. So it's another example of a potential threat and challenge to smart cities. Just one more slide before I kind of wrap up, and that's just to highlight another activity that the MetOffice are involved in, and that's the Natural Hazards Partnership. So this is a combination. It's actually a group of 17 government and quasi-government organisations that are coordinated to support the delivery of authoritative advice on natural hazards that are likely to affect the citizen. And this is just one example of those. This is we're doing a flood guidance statement here. And what we've done is we've taken the Met information, which is our knowledge and our science, the hydrology, which is not ours, it's more the Environment Agency, so it's another agency in the UK that deal with the rivers and the environment, and in this case it's more to do with the rivers and catchment areas and flooding, and the geo as well. Those three elements combine together as a service that goes out to both the public, emergency responders and utilities companies. So that's another powerful example of where we partner together to create services which empower and inform the public. Okay, I'm going to wrap up now with just a few challenges. And actually, I might need Chris to help out with these, or maybe in the discussions we'll get Chris to help out in these, because actually these are mainly Chris's challenges, although they're challenges for us. So hopefully you would have seen from that our data is both spatial but temporal. Every day we throw away terabytes of data, and the weather never stays the same from one day to another. So we feel that the temporal element, the time element of the data is vital and equally important as the spatial. So being able to support that, and so the next point is around extensions that support n-dimensional coverages. And so where the fourth dimension for us is time, I think that's quite important. We could quite easily add a fifth in terms of either the model runtime, or then you start to add in maybe the ensemble member, because we don't just run one model, we run multiple models. So being able to cope with n dimensions is going to be vital. How do we solve the query problem? There's huge potential to break any implementation of WCS 2.0, for example, by throwing a massive query at it that covers vast amounts of time and space and other things. That's another challenge. You've seen we produce a lot of data. Data volumes are huge. We're looking at how to actually, rather than transferring vast amounts of data from one point to another across networks, which is becoming infeasible, actually taking the problem and the challenge that you're trying to answer, the question you're trying to answer, to the data. So being able to do that more readily would be good. And then finally, interpolation. Generally not great for most Met data. We don't really want to interpolate and say that a temperature, for example, well, we've got one temperature of 10 degrees and another of 15, and say, well, it must be bang in the middle. It might not be. It might be a range or a percentage of probability that we want to describe. So interpolation is not easy and not good for our data. Okay, I will leave it there. Thank you very much.
Okay, we don't have a huge amount of time, so if there is one question, I'll go with one question. No questions at all? Actually, Mark, you didn't escape.
For just a comment, I really like the discussion of the potential solar impact on cities, because it really brings home the serious potential impact of externalities. You know, cities are, we tend to look at the city as a small ecosphere, but we don't really think about some of the externalities as much, and that one really brings home the real potential risk to smart city environments. So I'm just curious, as a group, what other externalities like that maybe might we not be thinking about that we need to include in these characteristics?
Yeah, thank you. I think it's a good point in terms of the typhoon as well. It's an external impact that comes from nowhere, and space weather the same, being very external to the city itself. So yeah, we should focus outwardly. Chris has a question, I think.
There's no question.
Oh, he has an answer. There we go. I'll run with the mic for you then.
It's a response to that.